Example number 71. Find the volume generated when the plane figure bounded by y is equals to cos squared x, the x-axis, and the ordinates at x is equals to 0 and x is equals to pi over 3 rotated about the x-axis. So what you want to find is the volume of revolution about, this is what is important, about x-axis. So for you to find the volume of revolution about x-axis, it is just pi, then we are integrating from a to b of f of x squared dx, where the limit about x-axis means we are integrating with respect to x. Are you seeing that? Yes. Where a and b are the limits of x, where x is from the intervals a to. So you see, when you say y is a function of x, it means where there is f of x, you put y, isn't it? So when y is a function of x, then it simply implies the volume is from pi a to b, f of x is y, so it is y squared dx. Are you seeing how to get the volume of revolution about x-axis? Yes. Meaning you integrate with respect to x. Are we together? Good. Now, having noted that, what we do, we substitute. We've been told between the curves y is equals to cos squared x, x-axis, and then ordinates x is equals to 0 and y is equals to 0. So if you want the region, remember the first curve here, we have y is equals to cos squared x, and the next bound here, x-axis is the line, y is equals to, are we together? So it means ordinates x is equal to 0 to pi over 3 will give us the limit, but we want the curve, the region between y is equals to cos squared x and x-axis, which is y is equals to 0. Are we together? So for you to get the curve defining that region, you subtract the 2, isn't it? So if you find the volume to be negative, it simply implies that you are subtracting a lower minus upper. Are you seeing? If you find the volume to be positive, then you are subtracting upper minus lower. Meaning this curve y is equal to cos x squared minus this. If you find the volume resulting from that given operation to be positive, then it means it was the curve which was coming on the upper region. Are you seeing that? Good. Now if you find the difference of the two, you let this to be y1, you let this to be y2, isn't it? Yes. Are we together? Yes. We want the region between y is equals to cos squared and x-axis. X-axis is the y is equals to 0. So if you let this curve to be the first curve to be y1 and this curve to be y2, then if you find the difference between of them, you will find the equation defining that region. Are you seeing that? Which is y1 minus y2, you get another y3, isn't it? Are we together? Yeah. y1 minus y2, it is another value of y which is different, isn't it? That is y3. So y3 is equals to cos squared x minus 0 is cos squared. Yes. So are you seeing? Meaning where we have y squared, the y we are going to integrate is what? Is y3, because it is the y defining the region between these two curves. Then the ordinates x equal to 0 to pi over 3 will now give us the limit. Are you seeing that? Yes. Are we together? So your y squared, the y which is defining the region is this. It is the y defining the region between cos squared x and x-axis is y3, meaning our y is y. Are we together? Yes. Our y is y3. So what is the volume? What is the volume? The volume is now pi, then we are integrating from x is equals to 0 to x is equals to pi over 3, then y squared. And our y defining the region is what? Is y3, which is given by cos squared x, then that y is squared, isn't it? dx. Are we together? So we found here we want to integrate. To get the volume, we are going to integrate pi from 0 to pi over 3. Then cos squared, if you square it, see the power outside multiplies the power inside. Yes. It means you have cos raised to power theta d. Is it theta? Yes. It is x. Yes. X d. Yes. X dx. So if we integrate that, we get the volume. Now you ask yourself, how do we integrate that, isn't it? We cannot integrate a cosine function raised to power, meaning we expand that cos into multiple angles, isn't it? Expanding that cos into multiple angles, we use De Moivre's theorem. And in De Moivre's theorem, you know that when you have 2 cos n theta, that is Zn plus 1 over, isn't it? And 2j sine n theta is Zn minus 1 over De Moivre's theorem, isn't it? So what do we want to expand? Cos. Meaning for cos you go, when n is 1, what do you get? When n is 1, what do you have? When n is 1, you'll have 2 cos theta to be Z plus 1 over, when you put n to be 1, because we want to expand cos raised to power 4, isn't it? Are we together? So we have 2 cos n theta is equal to Zn plus 1 over Zn. When n is 1, we get 2 cos theta is equal to Z plus 1 over Z. So that is what we want to expand. So here we have 2 cos theta to be Z plus 1 over Z. If we expand this, what do we get? What do we get? Raised to power 4, meaning we raise both sides of the equation to power. Don't worry, at the end, after we've expanded cos theta, we are going to let theta to be x, okay? There's no problem with that, isn't it? We are going to let theta to be. I was just using theta for you not to manipulate this concept. You just master this concept the way you know it, isn't it? Yes. Then after expansion is where there is theta, we put x. Are we together there? Good. So if you take the power inside, 2 raised to power 4, you get 16. Then cos theta raised to power 4, you get cos raised to power 4 theta. You've done this side of the equation. The other side of the equation is a binomial expansion. So a binomial expansion, when you have a power of 4, how many terms? 5 terms, isn't it? So 5 terms, that is the first term, plus the second term, plus the third term, plus the fourth term, plus the fifth term. So inside here, the first we have Z, isn't it? Z, 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 Z. Are we together? Then this other one, plus 1 over Z is just 1 over Z, isn't it? 1 over? 1 over Z, 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 then you put the powers, isn't it? So the powers 1 ascends, 1 descends, isn't it? So that one starts from 0. The reason why it is good to make this fraction start from 0, because anything raised to 0 is 1, isn't it? So we are not going to have a fraction at the start. Are we together? So that is 0 then, 1, 2, 3, 4. Then the other one descends. Now start from there as power 4. 3, 2, 1, 0. Then give me the coefficients when it is raised to power 4. N combination R. 4 combination 0, you get the coefficient here to be. Then 4 combination 1, you get the coefficient to be. 4 combination 2, you get the coefficient to be 6. 4 combination 5, this is 4 combination 2, you found 6. Then 4 combination 3, what is the coefficient? 4. 4. Then you move 4 combination 4, what have you found? 1. So you place the coefficients of the binomial expansion, isn't it? See, the next thing is to simplify. Are we together? So when you are simplifying, what do you do? Anything raised to power 0 is 1, meaning this one is 1, this one is also raised to power 0, it is 1, isn't it? Anything raised to power 0 is 1. Are we together there? Yes. Good. After doing that, what next? we collect. The ones with the same coefficient must always have the same power, isn't it? The ones with the same coefficient. So what do we have? Here has a coefficient of 1. This one has also a coefficient of 1. So you bring them together, isn't it? So if you factorize out a coefficient of 1, what do we have here? Z raised to power 4. Then the other one, positive. 1 over Z raised to power 4, you get plus 1 over Z raised to power 4. Have you seen you brought this term and that term together because they have the same coefficient, 1, 1. You factorize 1 outside. Is that okay? Good. Are we together there?
Yes.
Then go to the next one. Coefficient of 4 plus 4, isn't it? So if you factorize plus 4 side, Z raised to power 3, this is Z raised to power 1, isn't it? Z raised to power 3 minus Z, divide by Z, I mean you get Z raised to power. If you join it with the other one with a coefficient of 4, meaning you collected this, you collect that one, isn't it? So it means if this is Z squared, then you there you remain with 1 over Z squared, isn't it? 1 over Z squared, because you can see Z raised to power 1 divided by Z raised to power 3, you get 1 over Z squared. So what you put there is the sign, isn't it? See, the sign is positive, there's no negative sign there, isn't it? Are we together?
Yes.
You've collected coefficient of 4. The one which does not have a partner is always the constant term, isn't it? The one without a partner is the constant. Meaning this 6 is starting on its own, so you can just remain as 6. You can even see Z squared divided by 1 over Z squared. So Z squared cancels with Z squared. You remain with 6, isn't it? Good. After that, what do? You substitute, isn't it? Remember this side we have 16 cos raised to power 4 theta. So what is 16 cos raised to power 4 theta is what? Look here. Z raised to power 4 plus 1 over Z raised to power 4, you go here. It means when n is 4, where there is n you put 4, isn't it? So that Z raised to power 4 plus 1 over Z raised to power 4 is the same as 2 cos 4 theta. Are you seeing that? When n is 4, where there is n, if you put 4, when n is 4, you will see Z raised to power 4 plus 1 over Z raised to power 4. It's the same as 2 cos 4. Are you seeing that? So here we have 1 into this Z raised to power 4 plus 1 over Z raised to power 4 is the same as 2 cos 4 theta. You've dealt with that. Are we together? You go back to your problem. This was n, this was n, and the addition is what is in between, so it means we are dealing with this, isn't it? You go to the next one, it is plus 4 here, then Z raised to power 2 plus 1 over Z raised to power 2, where there is n you put 2, isn't it? Where there is n you put, so it means Z raised to power 2 plus 1 over Z raised to power 2 is the same as 2 cos 2. Are we together? 2 cos 2 theta. You get 2 cos 2 theta, then at the end it is plus. So when you are simplifying that, what are you doing? Simplify that. So you are dividing both sides by 16 to get cos 4 theta. 4 raised to power 4 theta. So you are dividing both sides of the equation by 16. So if you divide both sides of the equation by 16, divide both sides of the equation by 16, what do we get? Cos raised to power 4 theta. It is not cos 4 theta, it is cos raised to power 4 theta. It's different from cos 4 theta, isn't it? Cos raised to power 4 to be equals to, here is 1 times 2 is 2. 2 divided by 16, you get 1 over 8 cos 4 theta. Are we together?
Yes.
Then move to the next one. 4 times 2 is 8. 8 divided by 16, you get 1 over 2. So it is plus 1 over 2 cos 2 theta. Then plus 6 divided by 16. 3 over 8. Good. But now, what do we want? What do we want? Cos raised to power 4x. Meaning where there is theta, you put x, isn't it? Where there is theta, you put x. So we are going to get cos raised to power 4x is equals to 1 over 8 cos 4x, where there is theta, you substitute with x, isn't it? Cos 4x plus 1 over 2 cos 2x plus 3 over 8. So are you seeing? We've expanded cos raised to power 4x, meaning this one we can now integrate, isn't it? Are we together? We can now integrate that. So let us go back and integrate that. So what do we have? We have the volume, which is pi, then you are integrating from 0 to pi over 3 cos raised to power 4x dx. Are we together? We want to integrate the volume, which is v, which is pi, into 0 to pi over 3 is equals to cos raised to power 4x. So what is that? Substitute the value of cos raised to power 4x. What have we found? We found the value of cos raised to power 4x to be the same as what? 1 over 8 cos 4x plus 1 over 2 cos 2x plus 3 over 8. See, that is what we found. That is what we found down here. 1 over 8 cos 4x plus 1 over 2 cos 2x plus 3 over 4. Are you seeing what we found down there? This is, it was from 0 to pi over 3. Are we together? Good. So you are integrating that with respect to x dx, isn't it? Good. So start integrating. Start integrating. So here we have the pi, 1 over 8 is a constant, isn't it? Yeah. If you integrate cos 4x, integrating cos is positive sign, isn't it? So you get sine 4x, then you divide by the derivative within a function, that constant 4, isn't it? If you differentiate 4x, you get 4, then you divide by 4. So it is 1 over 8 times sine 4x. Divide by 4. Then here it is plus a half is a constant. We are differentiating cos 2. We are integrating cos 2x. If you integrate cos 2x, you get positive, isn't it? Yes. Positive sign. Then you divide by that derivative within a function, which is 2, isn't it? Yes. So if you differentiate 2x, you get 2. Are we together? Then you go to the next one plus. If you integrate 3 over 8 with respect to x, you get 3 over 8x because it is a constant, isn't it? If you integrate a constant, it becomes 3 over 8x. Because it is 3 over 8x raised to power 0, if you integrate x raised to power 1, which is x, isn't it? Are we together? Then you put the limits. What are your limits? 0 to pi over 0 to pi over 3. Are we together? 0 to pi over 3. Continue. So what we do is to substitute the limit. What we do is to substitute the limit. So remember, you are working in pi radians. So if you are working in pi radians, your calculator must be in R, not D, isn't it? Your calculator is in R. So let us start with the upper limit. We have pi outside, then upper limit, sine pi over 3. Where there is x, you put pi over. So you put pi over 3 where there is x. So here we get, first of all, can you simplify this to look neat? This is sine 4x over 8 times 4 is 30, isn't it? Then here it is plus sine 2x over 2 times 2 is 4, isn't it? Then it is plus 3x over 8, then you are integrating from 0 to pi over 3. So when you put this formula in the calculator, it will be very easy. Just say pi over 3 is equals to pi over 3, that is the answer, isn't it? Then you start. Get me the upper limit. So you've already placed pi outside the bracket. Yes. Okay, so what is the answer? You see, only the upper limit is enough here, because it is going to be upper limit minus lower limit. When lower limit is 0, this one is going to be sine 0 is 0. 0 plus 0 plus 0 when x is 0, isn't it? So it is now lower limit, the whole thing is going to be 0. So it means only the upper limit gives you the answer. Are we together? Good. So get me the value sine 4 pi over 3 divided by 2 plus sine 2 pi over 3 divided by 4 plus sine 3 pi over 24. That is what I have. 1 point? Everyone has 1.83, isn't it? So the upper limit is 1.83 minus the lower limit will be 0. Because if you substitute 0, 0 here, you will get the whole thing to be 0, isn't it? So upper limit minus lower limit, it just remains as 1.83. Somebody can also leave the answer in terms of pi, isn't it? But you see, if you leave pi here, here there is no pi, here there is no pi, so adding them, we will not add them to be one thing. So just what pi is 3.14 to approximate, isn't it? Are we together? So that is the solution of that given problem.